Hello guys, and welcome to the part 2 of this tutorial where we're making a Pygame sliding puzzle. And in the part 1 we created the game class and the game loop, and the grid where it's gonna hold our puzzle. So today we're gonna be working on the sprites class and the tile class, and maybe I will do the button and the UI elements class as well. So let's start with this one. We're going to, in the sprites file, we're going to import Pygame, and also we want the settings. So we're going to import everything from the settings. And we're going to be using the Pygame font. So we have to initialize. Is it font.init? Yeah, we need to initialize the font. And then we're going to create a class called tile, which will inherit from the Pygame sprites.sprite. Make sure that this second sprite is a capital S in there. Okay, we're going to create a constructor for this, which will take the game as a parameter, an X, a Y for the coordinates of the style, and the text, which is going to be the numbers. So it's going to be number 1, 2, 3, 4, 5, 6, 7, 8. And the number 9, in this case, is going to be an empty tile. Okay, we're going to create a group, self.groups, and that is going to take all the sprites. We're gonna have to create this instance variable after in the games class, and we're also gonna call the super constructor. So sprite dot init, and we have self inside, and we're gonna pass the self.groups as well. Okay, so we're just calling the constructor of the Pygame sprite, and we're passing this group inside. Okay, we're gonna have self.game is equals to the game. In this case, when we create this object in the game class, we're just gonna pass self inside, which is the actual game. And we're gonna have a X and a Y, which is X and Y. We're going to have a text, which is equals to the text. And we're going to have, I think on top here, we're going to create an image, which is going to be the pygame.surface. And it's going to take the tile size by tile size. So this image is going to be the tile size by tile size, which is just this size of each of the tiles. Okay. And we're gonna get the rect from this image. So self.image.get rect. Okay, what else do we need in here? Let's just define an update function. Not like that, just update. And the update, we're going to update the rect x to self.x times tile size, and also the y times tile size. So every time we update this, so we only need to pass the indexes in here, and that is going to times by the tile size, and it's going to give us the exact coordinates on the grid in pixels. Okay. Also, we're going to have a click function to check if we're clicking on this specific tile, and that is just going to return the, or actually we have to pass in here the mouse coordinates, which is going to be mouse x and mouse y, and we're just going to return self.rect.left less or equals to mouse x, which is less or equals to self.rect.right. And we're going to do the same thing for the y. So this is just to see, wherever we click here, is to see if the mouse coordinate is more than the rect left and less than the rect right. So that means it's inside of the rectangle on the x-axis, okay? So on the horizontal. Now we do end, and we're gonna do the same thing for the rect top. Needs to be so it goes up, needs to be less or equals to mouse y, which is less or equals to self.rect.bottom. Okay, so now we're checking the vertical as well. If it's less, if the mouse position is more than the top and less than the bottom, and less than the right, more than the left, that means it's inside. We're clicking inside of this specific tile. Okay. Okay, so now we're going to create a function in here which will create the actual game. So this function is going to create the list that will hold all the grids. So it's going to be a 2D list. So basically this list is going to be something like this. Okay, so we're going to have a list inside of a list. I just want to demonstrate to you what it's going to look like, this list. So 3, 4, 5, 6, and then 7, 8, and then this one is going to be 0. So we're going to create this function to create this two-dimensional list which will hold all the tiles. Okay, so this is going to be tile number 1, number 2, number 3, 4, 5, 6, 7, 8. And this one is 0, it means it's going to be an empty tile, okay? And every time we click on a tile, we're going to check if this tile is a number, it's not empty, and we're going to check to see where we can move it. So for example, if I click on the number 8, we're going to check on the right side, there's a 0 in there, so we're going to change the positions of the tiles. So that means the 8 slides to the right. Okay, so if we click on number 5, then we're just going to change the position of those two tiles. So this 5 slides down. And we're going to do that for all of them. And at the end, we can actually check, we can create another game grid to check if our game is the same as the completed grid, which is this one. And if it is, then we can end the game and the user wins the game, basically. So this, we're going to just create a little function in here to create this grid, okay? So there's two ways of doing this. One of them uses a nested for loop, and the other one just uses inline list creation, okay? So I'm going to show you the nested for loop first, but I want to also show you the other way, which is a bit faster. Okay. So the nested for loop, we're going to create two loops. So it's going to be in range of the game size. Okay, the game size in this case is 3. Okay, so 3 by 3. So we do in range of that game size. And also we have to create a list in here. So we're gonna call it grid is a list, and then we do the first for loop and we do grid dot append, and we're gonna append an empty list to it. And then we're gonna do another for loop which is also in range of the game size. And in here we're going to do a grid x append. Okay, we're gonna need a variable in here which we initialize as 1. So then we append the number 1 in there, because we want this list to increases. So we are not filling the list with this list with only zeros or with only ones. So we want that number to increase from 1 to 8, or in this case, it's going to be from 1 to 9, and then we're just going to change the last number to 0. So we initialize this variable as 1, we add in there, and then we increase the number, the variable. Okay, and then at the end, we can just take the grid -1, which is the last element, and we just change it to 0. Okay, I will just print this in here to show you. Let's call this in the new function. So self.create game. Let me see what's this gonna do. Okay, so as you've seen here, we're creating a multi-dimensional lists with the numbers 1, 2, 3, 4, 5, 6, 7, 8, and then the last element is 0, which is empty. Okay, so this is exactly the same what I just showed you in here before. And let's say we change this game size. Okay, so if you wanted a more difficult one, game size of 4. If I run this, then we get a list with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and the last element, which is in here, it's an empty one. Okay, that works for 5 as well. It works for any number. Okay, we'll just stick for 3 for this one. Okay, so this is one way of doing this, but I also want to show you another way of doing this. It takes less space basically, which is we're going to just create the grid straight away, and it's gonna be two grids inside, two lists inside. In here is gonna be x plus y times game size for x in range of 1, game size plus 1. Okay, and then for y in range of game size. So this code here does exactly the same as these for loops in here, and I'll demonstrate that as well. So we also just need to change the last element to 0. Okay, so I'm just gonna delete this and print this at the end. Okay, so if I run this, you see this gives me exactly the same, but it's written in one line. Okay, so I'm just going to be using this. So instead of printing here the grid, I'm just going to return the grid. Okay, so let's do this new in here. So where's the new? I'm creating the game. We're going to call this self.stylesGrid is equals to that. Okay, because this function here is returning the grid. So we're just storing this grid into this function here. And we have to do another one as well, which is going to be the tiles grid completed. Okay, so this tiles grid here, we're going to be changing it every time we click on a tile. And we're also going to be comparing this grid with this grid to see if they're the same. So if they're the same, that means we managed to finish the game. And also, I'm just going to create the group in here. So self.all sprites, that's what I called in here. Okay, this is, we're going to initialize a Pygame sprite group. Okay, so whenever we create an object of this, we're going to pass the game inside. That's why I'm calling the game.sprites in there. So we're going to be passing that game class inside of the object of the tile. I think that will make more sense when I start drawing the tiles on the screen. We're just going to do one more thing for this second part, which is going to be to draw the tiles in this screen. Okay, so now we can create the tile, or we can create the list where it's going to hold all the tiles. Now let's draw those tiles. So I'm just going to create a function. just here after the create game, and we're gonna call this define draw tiles. Okay, we don't need any parameters in there. We're going to initialize a list as empty, and we're gonna go on a loop in here. So for row and x and enumerate. Okay, so we're gonna take the row and so the index and the element. That's what the enumerate function do. And the self.tiles grid, not the completed one, the normal one. Okay, so every tile inside of that, every element inside of this list, we're taking the index of that and the actual element, the actual number. That's what we're gonna use as the text in here. Okay, and then the indexes we're gonna use for the position. So we do this, and then we do self.tiles.append, which is going to append the empty list in there. So we're going to be creating, again, a multi-dimensional list in here. And then we're going to go for column and y and enumerate x. So now we are enumerating every element on this tile list, which is a list, basically, that we are appending in here. I hope this is all making sense. Okay, and inside of here we're gonna say if the tile if y is not equals to 0, that means we have to draw a tile. Okay, so this grid in here, we go from 1 to 8, and the last element is a 0, which is an empty space. So if the tile in here, let's call this tile, I think is better. Tile. So if the tile is not equals to 0, if the element is not equals to 0, then we append to the row, we're gonna append the tile in there. Okay, and here's what I said. So we need to pass the game, which is this class. So we just pass self inside. Okay, and then the x and y is going to be inverted in here. So it's going to be column and row. And then it's going to be string of tile. Okay, which is the numbers. And if it is a 0, what can we do in here? We're just gonna append to the row as well. We're going to append the tile, which would take the same thing, but in here we're gonna call it empty. Because later when we're clicking on the tiles, we're gonna check if the tile text is not empty. That means we're selecting a tile with a number. And if we're clicking on the empty space, nothing should happen, basically. I think that's it for this draw class tile. We're going to test this by calling it in the draw function. So draw tiles. Let me see if this is working. Not yet. I think we need to update this. In the update function, we have to call the self.allsprites.update. Let me see, it's still not showing there. Let me just see what am I doing wrong in here. We have to draw all the sprites as well. So allsprites.draw. Is it this the function? We need to pass this screen here. Yeah, we haven't created this function here, the draw. I don't know if you noticed, but this draw function comes from the sprite class, which we're inheriting from. Okay, so it draws all the sprites in this group of sprites. Okay, and we have to pass the self.screen inside. So if I do this now, okay, everything's black. That is because we haven't put anything in here. So now we have to tell this class to draw the numbers. Okay, so I think we're gonna do that before we finish this. In here, just after we get the rectangle, we have to check whether the text that we're passing. So in here, when we create this object, we're passing a text, okay, which is going to be every number from 1 to 8. If it's empty, then we're going to pass empty. So we need to check if this is empty or not. So if it is empty, we don't draw any tile on it. We just draw a blank tile, basically, with the same color as the background. But if there's a number on it, then we have to actually draw a white tile with the number in the center. So we're going to check if this text is not empty. Oops. Empty. Then we're going to create this font. So self.font is equals pygame.font.sysfont. And we're going to be using consolas and with a size of 50. So this is just to start with the font. Okay, so sysfont takes a font family and a font size. And we're going to create a font surface as well, which will take that font that we just created in here, okay, and we're going to render it the self.text to it. The second argument is the anti-alias, so it's true or false. True, it makes the border smoother. False, it makes it very square borders, basically. And the last one is the color, which we're going to be using black. That comes from the settings that I've done before. Okay, and then we're going to call the image. We're going to fill that the whole square with white. It's going to be a white square. And we're also going to call self.font.size. Sorry, it's font underscore size is equals to self.font.size, and we're going to pass the text inside. And then we have to blit it. So image.blit, and in here we have to pass a font surface and also an x and y coordinates. If we just pass self.x, self.y, it's not going to be in the center. Okay, let's just pass this just to test. So let's run this and see what happens. Okay, so now we have the tiles. Do you see it? So we have every square, they're white, and they have the black color that we passed in here. Okay, so we're creating that font, we render the text, we fill the image, which is the surface that we determined in here, which is the tile size by tile size. We fill it with white, and then we blitz the text to it. Okay, so we take the font to surface, which has the text on it, and we blitz into that image. And so if we pass the self.x, self.y, it's gonna render the numbers from the top left corner. Okay, but we want these numbers to be in the center. So to do that, we're gonna create just two variables in here, which is gonna be draw x and draw y. So the x, this is just a formula, okay, to put the text in the center. So we're gonna take the tile size divided by 2 minus self.font size. That's why we created this. Okay, so this takes it exports like it returns a tuple. Okay, for the size of the text. So the x and y, the width and the height, I guess, of the text. Okay, so we're gonna take that, and we're gonna take the first element, which is the width, I think. and we're going to divide that by 2. So we're going to copy this, and we're going to paste it to the x to the y, but we're going to change this one to 1. Okay, so this is just a formula to get this text in the center, and then in here we just pass the draw x and draw y. Okay, so let's try to run this now and see. And there we go. So now the numbers are in the center. If I click on them, nothing happens because we haven't really specified the events yet. So I'm going to stop here for this part, and I'll see you guys back on part 3.